Okay, so what we're going to get started on now is the pre-lab stuff for the properties of compounds lab. Now, for this lab, I'm literally going to hold your hand and walk you through the lab report. So, like, I'm going to be giving you a lot of, like, hints slash most of the answers slash whatever, okay, for the different parts, because this is your first one, okay? You've never done a high school lab report before, okay? So you kind of need to see what it looks like and kind of be walked through it on the first time, okay? So if you pay really close attention and you're working in the lab report template, so okay, that's what you want to have open right now. If you go to the properties of compounds lab here, okay, and open up that Google Doc, okay, so that you have this document open, you're going to want to be typing in there as we go along, right? Because I'm going to be outlining, here's the manipulated variable, here's the responding variable, okay? Here's the things I'm looking for in the explanations so that you can kind of put them in there, obviously in your own words, okay? But put them in there so that you know what the expectations are and you do a good job here. Okay, so for this lab, the problem that we're investigating is how we could identify unknown compounds using just their physical properties. I have a very long-winded, non-question problem at the top of this sheet. Obviously, you don't want to copy that, okay? Because that would not be right. It's not a question, and it's really long-winded, okay? But the purpose of this experiment is to be able to identify unknown compounds using only their physical properties. You need to write something that expresses that in the form of a question. Zach?
We can use like we in our problem.
We try not to. We try to avoid the use of we at any point in a lab report. Okay? Right, so you're trying to make a question out of this. Probably it's going to be a how question, okay, as opposed to a why or a what, okay, or a who. I'm not really dealing with that. This is more of a how question. The point is trying to identify 12 unknown compounds based only on their physical properties. Okay? We need that as a question. It's probably a how question. Okay? It's a short sentence. It doesn't need to be a paragraph or anything like that. So the next part of our lab report are the variables. And as we said before, we need to be able to not only identify one manipulated, one responding, and 3 controlled, but also explain them. So in order to do that, we kind of need to know how the experiment is going to work so that we can figure out what's being manipulated, what's responding, okay, what am I going to have to control throughout the lab. So the lab's going to work like this. We talked about the tests we're going to run yesterday. Every time we run those tests, that was the observable properties where we check the color and all of that kind of stuff, okay? The solubility test where we see if it dissolves in water, okay? The aqueous conductivity test and pH test, those are all the tests we're running. Every time we run those tests, we're going to be running them on a different unknown material. Okay? Each time this experiment is run, we as the experimenter are changing what material gets tested. Okay? We're testing all the materials the same way. Okay? Every one of those materials is going to be tested using the exact same set of tests, the exact same procedure. Okay? But each time we run that procedure, it's on a different unknown material. So what are we manipulating? It's okay, you can say the answer. What are we manipulating? Each time I run the experiment, it's on what? A different compound. Okay? The compounds are our manipulated variable here. Okay? That's why I made such a big deal of saying, I'm going to test them all exactly the same way. using exactly the same test, I'm also trying to give you some of the controlled variables. Okay? So remember, when you're explaining why the compounds are a manipulated variable, right, you need to tell me how they're being manipulated and why. We haven't talked about the why yet. We've kind of talked about the how, but we haven't talked about the why. Okay. So the premise behind this lab is that all materials have different physical properties. Agree? When we have those 12 unknown things on the table, there's no two of them that have exactly the same physical properties. Would that be true? Okay, so that's the premise we're working on. Okay, so that has to do with the why for the manipulated variable. Okay, why are we testing a different one each time? There's no other way to find the identity than to use the fact that they all have unique physical properties. So if you do a good job of identifying and explaining a manipulated variable, I'd say you're probably looking at 3, maybe going on 4 lines worth of text.
Sorry, what was the why?
I didn't exactly outright say what
Yeah.
the why was. Okay? What I did say was the premise of the lab is that to identify these, they all have to have unique physical properties. Which leads to the responding variable. What am I recording in this lab? Every time I test a new unknown compound, what am I recording about it? What are all of these things? Okay, I'm thinking of 2 words that go together that both start with P.
Physical properties.
Ah, there we go. Okay. The physical properties are what we're using to identify them. Every time I run the tests, I should get a different set of physical properties. Now I keep saying I. Do you want to say I? You don't. I keep saying it because I'm up front and I'm explaining something. Okay? But in your lab report, okay, you don't want to use the word I. Okay? So the responding variable in this experiment is the physical properties or unique physical properties of each unknown compound. You have to explain how that responds and why. Okay. The how part is actually pretty easy. Okay. How it responds is basically every unknown compound has different physical properties. Okay. The why is a little bit trickier. Not so much tricky, but you have to look back at something we talked about before. On the first day, when we were talking about the atomic structure of matter, we said that it's the structure of the atoms that gives each element its own physical properties. The same is true for compounds. Whatever happens to be in there, the combination of protons and neutrons from different atoms and the combination of atoms is what's going to contribute to physical properties. So something along those lines is what you need to explain the why. Okay? All compounds have different molecules or different atomic structure. Okay? next thing that needs to go in are our 3 controlled variables. Now, when we're deciding what things need to be controlled, we have to think about a couple of things. The first thing we have to think about is, what are we trying to test? And then, what things could affect the results of those tests? So if I'm running a series of tests that are trying to find the physical properties of these unknown materials, what are some things that could maybe get in the way of that or possibly interfere with my results? Okay, so yesterday I was showing you the box or the plate that you were going to use here. Okay? A depression plate like this. When I'm putting unknowns in here and I'm trying to do a fair comparison of them, what should I make sure is the same about all of them? How much you put in. Absolutely. Okay? It's hardly a fair comparison if I put 2 grains of one thing in here, and then the next one I fill the thing all the way to the top. That's not going to help me get a good comparison of physical properties, especially when it comes to the solubility test. Right? I'd get the other thing probably to dissolve really easily because there's practically none of it. The other one I'd have like a sludge because I'd never have enough water in here to make it all go away. Right? To give you an idea on this, I don't know if you can see it, but there's still salt on the bottom of that depression, and I only barely covered the bottom of the depression with salt. Okay, like just covered it. I didn't have like a layer of salt this thick or anything like that. I just covered the bottom. Okay. Now, is that a good measurement or is it kind of approximate? Like if I was to say in my procedure, just cover the bottom of the depression with the material, is that a measurement or is that an approximation? It's an approximation. For what we're doing, measurement's not overly important, but if I was really wanting to be careful, I'd probably get like 1 gram of everything. I'd put it all on a balance or a scale or whatever and get exactly 1 gram of everything. And we used to do this experiment that way. The problem was when we did it that way, it took 2 days to do it. Okay? Because you had to measure all 12. Okay? And there's only so many scales, and it just, in the end, it didn't get better results than just go and cover the bottom. Okay? Like we don't really need anything exact here. If we were reacting things and having to record how much product we had, then yeah, we'd have to measure. Okay? But for this, it's not really that important. Okay, so remember, for every controlled variable, we're identifying it, and then we're explaining how we're controlling it and why we're controlling it. Okay, I think we kind of explained that for the amounts already. Okay, now, given some of the tests that I'm running here, particularly the solubility test, what else should I make sure is the same about all of them? And I'm thinking especially for the solubility test.
The amount of water used?
Okay, I would say, yeah, probably the amount of water would be important and something else. Yeah, the temperature of both the material and the water. Okay, that can affect your solubility test. Okay, that's got to be controlled. Okay, that's something that would affect the experiment, and you can tell me how. Okay, you know what effect temperature has on solubility. Okay, you can tell me that those aren't kept the same. This is how it would affect the experiment. It would be, tell me how that would create an unfair comparison. When you're thinking about, like, you've got the Y there, but how are we making sure the temperature is the same? Yeah, exactly. They're all gonna be in the room over there, which is the same, I mean, there's no part of that room that's like super cold, okay, or super hot. So, yeah, they're all gonna be at room temperature. All the samples and the distilled water are all going to be at room temperature because they're stored in that room together. Okay, now I'm not gonna outright tell you the last controlled variable, but I'm gonna repeat something I said earlier that can help you with it. What I said earlier was this. For every unknown compound, they will all be tested the same way. Okay, they will have the same tests run on them. Okay, they'll all have the same procedure run or whatever. Okay, that was something I said earlier, so maybe that'll help with it. And remember, you have to explain how and why. Next thing is our hypothesis. What 3 words need to go in our hypothesis? If, and, then. Okay, those 3 words need to be in our hypothesis. So, reminder, the if part of a hypothesis deals with the premise that we are working on. Okay? The idea of this experiment is to identify unknown materials based on their unique physical properties. We won't be able to identify these compounds unless they do in fact all have unique physical properties. So I would say that in the if part of your hypothesis, you should probably talk about just that. Okay? That compounds must have unique physical properties. You got to find some way to make an if out of that idea, because it is that idea that will allow us to identify them. All right, so the if part should talk about that premise. Figure out how to wordsmith it for yourself. The and part describes the experiment. Again, don't go into detail. You're going to be writing a procedure here that's going to be step by step. Here's what to do and how to do it. Okay? The and part of the hypothesis just needs to briefly tell us tell other people what you're going to do. Okay? So it can be very general and very kind of nondescript. Okay? In this experiment, the following tests will be run to determine physical properties of materials. Okay, so you can talk about the tests that we're going to run because we talked about those yesterday. Okay, observable properties, solubility, aqueous conductivity, and pH. Right? You don't need to say how you're going to do them. Just these are some tests that are being run to get a good list of physical properties or to determine adequate physical properties. The then part needs to predict your results and or explain what you're going to be able to do. In this case, it's a little of both. Okay? So the idea that we're working on, again, is that everything has unique physical properties. We're running a bunch of tests to determine those physical properties. What am I hoping to do with those physical properties? I'm hoping to identify the materials because every material is going to have a different set of data. Okay, so that's like my predicted results are every unknown compound will have different data / physical properties. Okay, what am I going to do with those? That's the then part. Okay, so we've already predicted that every compound or every unknown is going to have its own set of data / physical properties. What am I going to be able to do with that? That finishes off the then part. Okay, you tell me. Don't write what am I going to be able to do with that. Tell me what you are going to be able to do with that. So tomorrow's class is going to be dedicated to you and your group making your procedure. So I'll talk about how you write that and all that kind of stuff tomorrow.
Where are you taking it to?
No, you guys can pick it. Just make sure everybody's included. Okay? So you guys will be writing the procedure tomorrow. What I want you to spend the remainder of today doing, okay, is this. In the materials are all of the possible identities of the unknowns. Okay? So what would be a good idea for you to do today, for the remainder of today and probably part of tomorrow, would be to brainstorm with your group, what do you think the physical properties of some of these materials are going to be? Okay? Is that material ionic or molecular? If it is, what is that going to mean for its conductivity? Is it going to have a certain color? Okay? What are some things that that particular compound is going to show? And we talked about those yesterday. Right? If you recall, we talked about how some metals produce salts with a certain color. Okay? And we know that some of the properties of other things, like we know the properties of water. Water is one of the unknowns, so you know what that should look like. Okay? So there's a couple here that we're just going to run through because there's a couple I want to give you tips on. So let's look at this first one here. Ammonium nitrate, NH4NO3. Is that ionic or molecular? It's ionic. They're two polyatomic ions. It's tricky. That's a tricky one because it starts with N. Okay, it starts with a non-metal, right? But this is that one polyatomic ion that's positively charged, okay, ammonium, and it's with another polyatomic ion, nitrate. So this is an ionic compound. Okay, and if you recall, we said ionic compounds are typically highly soluble in water. Their solutions will conduct electricity. Okay, they're all going to be crystalline solids at room temperature, right? Stuff like that. So that's kind of the brainstorming that I want you to go through. The one thing I am going to tell you about ammonium nitrate is this. Has anyone ever used one of those cold packs where you pop the little water bladder and then shake it and it gets cold? Okay. Ammonium nitrate is the active ingredient in cold packs. Okay? It's a crystalline solid. They put it in there and then there's a little water bladder inside the cold pack. When you rupture it, the water gets out and starts to dissolve the ammonium nitrate. That process is endothermic, which means it takes energy, so it gets cold. Okay? So ammonium nitrate, when it dissolves in water, gets colder. It's kind of an important thing you need to know when you're trying to identify it. Okay? One of your solubility tests should get colder. Right? So that's the process you should go through. And I don't expect that you're going to know necessarily all of these, okay? But you should be able to get a pretty good start on brainstorming what you think the physical properties of each one of these things is going to be. All right? Now, just for some things you might not be familiar with, what's paraffin? Anybody know what paraffin is? Paraffin is candle wax. Okay? It's what candles are made of. Okay? So it's C25H52. Right? Flammable. That's why candles burn. Okay? But you kind of know what candle wax looks and feels and smells like. Okay? So you have some experience around that. I think the rest of those things you probably have a pretty good idea on. Okay? Also want you to know that in here, there is one strong acid and one strong base. And you should be able to figure out which one is which based on their chemical formulas. And the stuff we went over yesterday. Okay? So you will need your notes from yesterday. Lesson 4. Okay? They can help you with some of that brainstorming. All right, I'll let you guys kind of do a little brainstorming together here. I'm going to come around and wipe down the Chromebooks. Okay, so if you can log out and then power them down, but leave them open. Okay, I'm going to come around and wipe them down. Once I've wiped yours down, you can put it back in the cart in the appropriate numbered slot.
Uncle.